And the homework is not due today. I think I have a typo. It should be due tomorrow, right? Tomorrow 1 p.m. Then today will be our last lecture. I will try to finish everything. Then Friday we have the test 6, and then Monday I'm going to review the test 4, and then give the review of the final test, the final exam. So for this one, we can decompose using the superposition principle and decompose into the combination of the loading. So one is under distributed loading, and the other one is under the point loading like this. So from here, we might be able to use the table and see the value of the tables. Here I have still plenty of the copy of the table. If you would need one, come over to pick one. So for this case, we can use, if you have the tables with you, this will be case 6. And for case 6, and we can see that is the deflection will be like this, and then we call this is a Y1. How about C? 6, Y6. Okay, so from the table we can calculate, we can see the Y6 is minus omega 24 EI, and X4 minus Q L X3 plus L3X. Okay, the L is the total length of the beam. And this one is our case 1, 2, 3, 5. Okay, because the point loading is not at the middle, so we shouldn't use case 4. Case 5 will be more appropriate. So for case 5, here we have 2 ranges, and say right now, here is the L over 4. So for case 5, for example, for the X is in between 0 and L over 4. And
Why is it L over 4?
Just 2 and 6.
L over 4.
3?
Or L over 4 because it's 8. So 8 total. 2.
Oh.
2 divided by 8. Right. Sorry, I stress you too much. She is in my other class, the astrodynamics ME 400 level. I give the students 1 whole week to complete the final test. You could imagine how rigorous the final test will be. I'm sorry, not only you, the other Tim. Is Tim here? Oh, yes. Yeah. Congratulate for Tim. He the put into the final 2020, right? Yeah, the rifle shooting. I mean, go for Olympic trial. Yeah, congratulations.
Thanks.
So for this one, let me say this. In this range, the Y, let me call using the symbol 4. Symbol 5 to indicate this is the case 5, and then we can copy from the information. Here is F times what is B. B is here. B is 3L over 4. So for this case, this mapping to the information is L over 4. B is 3L over 4. Using this information, we plug into here. B is 3L over 4, and then 6E I L and X cubed minus L squared minus 3 over 4 L squared times X. How about the X in the L over 4 and L? For this one, this table doesn't supply any information. And here I can provide to you. So for this case, if we really want to look for And we have to start it from the beginning. So you have to derive it. And this one, let me write up my final answer. That would be minus 1 EI minus 24 P using F.
Professor?
Yes.
For the first Y5 case, trying to a bit confused by your parentheses in the X. Yeah, there's.
Let me double check. So that would be x cubed minus L squared minus B squared, right?
Okay, so that's L
And
squared
B
minus
is
B
this one.
squared. Okay.
Yeah.
So those are separate terms.
Yeah. And how about this? Let me say this is the left hand part. This is the right hand part. So let me say this is phi L and phi R. That be okay? So one is in the left range and one is the right range. So make the two things for the labels. Okay. And now we're looking for the Y max. So the solution, the concept is this: as long as we have these formulations, then we simply do the derivative and taking it equal to 0, and for solving x, and that is for x equal to x star. And where the maximum or the minimum would occur. Okay, so that is our the strategy for solving this. So as long as we have a formulation, then we can take the derivative setting up to 0 to find the locations. Right now we have the formulations. So in this way we have two ranges. The one is in x in 0 and L over 4, and then also we have the x in L over 4 and L. We have two ranges. So in this range, the y of x will be equal to y6 plus y5 Lx. Okay, this one y of x will be equal to y6 plus 5 Rx. So we have those kind of information. Then we simply take the derivative. We see what happens. So here we take the derivative of y x equal to 0 in this range. Then for that case, plug in all the information, do the derivative, and then solve for the equations. And that equation, after a few minutes, I think probably will take you 10 minutes, plug in all the numbers appropriately. And then this one will be leading to this case, and that one will be minus 3.33 x cubed plus 96.25 x squared minus 492.3 equal to 0. So that is the equation corresponding to this one. Then therefore the root will be equal to x equal to 2.36. The other two roots are negative, we won't consider. Okay, so that is the answer. That is the x dot. That is where the maximum would occur corresponding to this function. Again, this function is valid in this range. Is this answer good?
Check that one.
No. Why? Because this is between 0 and 2. Somehow we find this range, this answer is outside this range. So this is not good. The reason why is this one is outside the range here. So we're looking for this one. So dy dx equal to 0. So again, do a little bit calculation. Minus 3.33 x cubed minus 20 plus 21 q5 x squared plus 300 x minus 1. Okay, that is this polynomial equations, and then the roots will be equal to x will be equal to 3.76. This value falling into this range equal to 2 and 8. So therefore, the maximum would occur in the right range, not in the left range. Okay. So plug in the x into this value, then therefore the x dot, the y maximum, let me write it up here. So therefore, the y maximum will be equal to y x and 3.76. Okay, so that will be equal to y, and y is y6 plus y5r. Then here you simply plug in x dot equal to 3.76. Plug in the information here, then you will get is minus 21.75 millimeter. Minus simply means downward. Okay. You might ask me, how do I calculate the roots for this one? That could be the question you might ask, right? How many of you don't know how to run MATLAB? How many of you, everyone knows running MATLAB, right? Heard about the MATLAB? Done that before in ES 201, the numerical programming. Go to SoCal, and SoCal has MATLAB installed. You fire up the MATLAB, and once you fire it up, then in the MATLAB, the main screen, you will see this kind of the cursor. In the cursor, you simply type in root. And this is the round bracket. And then using the square bracket, the square bracket simply write it out the coefficients of this polynomial in the descending order. So that means here you put in minus 3.33 and comma, and 21.25 comma, and then 300 comma minus 1251.67. So this command, once you hit the return, then right away the MATLAB will give you the three values. X equal to, the value will be equal to certain three values, and then you pick the positive one. Yes?
So you just put in zeros if you skip an order?
Yes. If the polynomial will be, say, x3 plus x plus 1 equal to 0, then you simply put in its roots. Here, the roots. 1, 0, 1, 1, like this.
Thank you.
Okay. So using that one, that will help you. But in terms of the task, if we would have a similar question like this, I will try to manipulate the numbers for you. You can do it by hand. Okay. How to do it by hand? The do it by hand would be like this. For example, if you have the ax squared plus bx plus c equal to 0, then the roots should be equal to 2a minus b plus c squared minus 4ab. At most, I will have this kind of format, and nothing more will be more challenging than this one. Okay.
All right, quick question.
Yes.
So that produced an answer that was outside the
range.
Right. So because the overall deformation is like a piecewise function, it seems like you could have.
The overall could be like this. Let me draw this right.
Right. So it seems like you could have a local max or min
in each range.
Yeah, and then you'd have to just evaluate.
Yes.
Okay.
Yeah. So his question is, in each range, for example, in in the left range, the maximum is here, but globally, the maximum is here. Okay, so that is his question.
So even if that fell, that 2.36 fell
Fell?
under 2, you would still have to do the other side
Yeah,
to see if
no.
you got a bigger?
So in this way, the 2.6 is outside this range. So
Right.
right away, you can tell the maximum will be either on the boundary side of this range, either one. Okay, from the graph here, you can see the maximum is at here. That is on the boundary at this point. Am I okay?
What she's asking though is like
Oh.
if you get like 1.9 for your x there,
Oh.
do you have to do the other side then, or do you
Oh.
stop?
See which one's
Okay,
larger.
so if you would find the maximum right away falling into this range, you could stop. And that should be in this range. But you can double check, continue to do this calculation to confirm. But actually, they only have one global maximum. So once you find it, you verify it, that should be there.
Okay.
Any other? Okay. So that is for this question. And then the next one, I'm going to I'm going to call name, and then I don't know whether you've been seeing the teachers doing this before. Really, in this country, in the United States,
Maybe a Catholic school or something.
in which school?
Catholic school,
Catholic school, they do the same old style.
sometimes.
Really, in the current days, I thought that is illegal in the.
Depends on how much the parents complain.
Oh, the parent, that is requested by parents. That is requested by parents. Okay, I got it. Okay. I received about more than 50 emails from your parents asking to do so in the last lecture, and want me to give you a lesson. Sarah, especially your parents.
Yeah, probably true.
Right now, I'm going to go over one homework example. This is the little bit tricky one. And let me describe the problem here. So I'm going to use the stick to demonstrate the information in question. I came from Taiwan, and we use the very different education culture or style. And teachers bring the sticks and hit students, even if you got the high school say 90. But he said for your standard should be 100. So 1 point off, 1 hit. Compared to other students, say that student's standard is 80, so he got hit. He got 78, and he only got 2 hits, and I got 1. I got 10. So eventually, that become the daily practice, and as we as a student, we were not taken so seriously. Then one time she hit me, I hold it. And by the time I'm teenagers already, I hold it. And she said, please, no. And then one day in that lecture, she asked me to stand outside.
I'd rather stand outside.
And now you live in America.
I'm glad I'm right now in America. No, I'm bad. I feel bad that right now in America, I'm the teacher that couldn't hit you. Right, so I wouldn't, no.
At least like
You say that now.
you never had your like parents as one of the teachers, right? Because then you get hit no matter what.
So this is a homework, I think the homework, the problem 3. And some of you have asked me about this question, but I think this question has a lot of things to deliver. So this is a very important application. So for this one, this is a combination of the beams. Both of the beam, they made of the same material, has the same Young's modulus, moment of inertia I, and the same length L.